we start chapter number 3, polynomials. In an algebraic expression, if the powers of the variables are whole numbers, then that algebraic expression is known as polynomial. For example, m cube plus 3m square minus 25. 1 upon 4 n raised to 4 minus root 27. In both examples, the power of m is 3, 2, power of n is 4. So all these are whole numbers. So these are called polynomials. But next example, root y plus 5 is not a polynomial because the power of y is 1 upon 2 and 1 upon 2 is not a whole number. Constant polynomial. For example, 27 minus 3 upon 5. These type of expressions are called constant polynomials. We write types of polynomial based on number of terms. First type is monomial. Monomial means there is only one term. For example, 2x x cube. Next type is binomial, means polynomial having two terms. For example, x plus 5 x raised to 13 minus 2x square. Third type is trinomial, means polynomial having three terms. For example, x square plus 5x minus 6. Next topic is degree of a polynomial in one variable. What is meant by degree? The highest power of the variable is called the degree of the polynomial. Suppose the polynomial is x raised to 4 minus 27x cube plus 12. Then degree of this polynomial is 4. 29 is a constant polynomial. So degree of that polynomial is 0. Degree of a polynomial, if there are more than one variable, the highest sum of the powers of variables in each term of the polynomial is the degree of the polynomial. For example, 3m square n cube plus 4mn cube minus 27mn. In this polynomial, degree is 5 because in first term m square n cube addition of 2 and 3 is 5. In second term m raised to 1 n cube addition is 4. And in third term mn the addition is 2. So 5 is bigger. So degree of that polynomial is 5. Next, types of polynomial based on degree. First is linear polynomial. If degree of polynomial is 1, then it is called linear polynomial. For example, 3x minus 1, 7y. Quadratic polynomial. Polynomial having degree 2 is called quadratic polynomial. For example, x square plus 5x plus 6, 2y square minus 49. And third type is cubic polynomial. If degree is 3, then that polynomial is called cubic polynomial. For example, y cube plus 17y square minus 9. Now we solve practice set 3.1. First question. State whether the given algebraic expression are polynomials. We have to justify. First example, y plus 1 upon y. It is not a polynomial because in second term the power of y is minus 1. 2 minus 5 root x. Root x means x raised to 1 upon 2. So 1 upon 2 is not a whole number. So it is not a polynomial. X square plus 7x plus 9. All powers are whole numbers. So it is a polynomial. 2m raised to minus 2 plus 7m minus 5 is not a polynomial because minus 2 is not a whole number. 10, it is a constant polynomial. Next question, write the coefficient of m cube in given examples. So first is n cube, so coefficient is 1. In second, coefficient of m cube is minus root 3. And in third example, coefficient of m cube is minus 2 upon 3. Write the polynomial in x using the given information. Monomial with degree 7, so we write x raised to 7. Binomial with degree 35, so that example is 2x raised to 35 minus 7. Trinomial with degree 8, so x raised to 8 minus 7x square plus x. Write the degree of given polynomials. First is root 5, degree is 0, constant polynomial आहे. X raised to 0, so degree is 0. X raised to 2, degree is 2. Root 2 m raised to 10 minus 7, the highest power is 10, so degree is 10. 2p minus root 7, so that degree is 1. Similarly, for next examples, degrees are 5. And in 7th example, xyz plus xy minus z. So index of xyz is 1, 1, 1, that is 3. So sum is highest, so degree is 3. And in last example, sum of powers 3 plus 7 is 10. 5 plus 1 6, 1 plus 1 2, so degree is 10. Next question, classify the following polynomials as linear, quadratic and cubic polynomial. Now first 2x square plus 3x plus 1, degree is 2, so it is called quadratic polynomial. 5p, degree is 1, so it is called linear. Root 2y minus 1 upon 2, degree is 1, so it is called linear. In next, degree is 3 m cube, so it is cubic polynomial. A square, degree is 2, so it is quadratic polynomial. And last one 3r cube, so it is cubic polynomial. Now we have to write the following polynomials in standard form. Standard form means we have to write the terms in descending order of their odd powers. So m cube plus 3 plus 5m, we say it is m cube plus 5m plus 3. And in next example, the highest power is 5, so we write y raised to 5 plus 2y4 plus 3y cube minus y square minus 7y minus 1 upon 2. Means we have to write the powers of variables in decreasing order. Next is write the following polynomials in coefficient form. Now coefficient form and index form are very important in synthetic division method. So first is x cube minus 2. Now degree is 3, so coefficient must be 4. So x cube, then x square, x and then constant. But middle two terms are absent, so we take 0, 0. So we write coefficient x cube, so coefficient a 1, x square is absent, so it is 0, x is absent 0 and minus 2. 5y, degree is 1, so coefficient must be 2, so 5 and 0 because constant term is absent. 2m raised to 4 minus 3m square plus 7, degree is 4, so coefficient must be 5, so 2, then cube term is absent, so 0, minus 3, m term absent 0 and constant 7. Last question, write the polynomials in index form. 1, 2, 3, so coefficient is 3, so degree is 2, so we write x square plus 2x plus 3, 5, 0, 0, 0, minus 1, so 5x raised to 4 plus 0x cube plus 0x square plus 0x minus 1, minus 2, 2, minus 2, 2, terms given as 4, so degree is 3, minus 2y cube plus 2y square minus 2y plus 2. And in last question there is one activity, so solve that activity.